Okay.
Hello, welcome to the ZSM Forum's next session, Intent and AI-Driven Autonomous Operation. And your speakers for today will be Magnus Borgard, ETSI ZSM 011 Rapporteur from Ericsson, and Laurent Tivalier for ETSI ZSM 012 Rapporteur for Nokia. I'm going to hand you over to Magnus. Thank you.
Thank you very much. My name is Magnus Borgard. I'm the rapporteur of this ZSM 011 intent-driven autonomous network study. So I'll go to the next slide. Already in the ZSM architecture framework specification, it has been indicated that we have support for intent-based interfaces. But in the beginning, we didn't put that much sort of effort into describing that. That's why we have started this work on in the study. The general properties of intents are that they're declarative goals and utility. So intent is declarative rather than imperative, leaving its implementation open. So intent is ideally an expression of utility, estimating a notion of what properties of the outcome are satisfactory, rather than requiring a specific outcome. So it's infrastructure agnostic and portable. It's not device or infrastructure specific. Intent is variant with respect to the user expectation. So and it can be contracts and changing requirements, but decoupled from variations in the underlying infrastructure. And this makes intent portable across vendors, implementation, etc. So this is an important aspect that you can put an intent from your own perspective and not thinking of exactly how or who will execute that. It's composable and additive. Multiple intents may be given to the autonomous system independently, and the system is expected to consider them together. It's complete and exhaustive. Intent is describing all aspects comprehensively. And if a requirement or concern is not described by intent, it's not recognized as required or relevant. And persistent, it stays until it's actively removed. It's a knowledge object with actively managed life cycle. This is important that it's not part of sort of the putting up the network. It has its own life cycle and it has its own sort of dynamics. In the study direction, I mean, we see that the ZSM framework is getting traction as a clean, straightforward description of a service-based architecture for zero-touch automated network and service management in a multi-vendor environment. And the concept of intent-driven management is not new, but it has lately gained renewed attention as a key ingredient for autonomous networks and zero-touch operation, as a possibility to bridge consumer expectations and network abilities. So as the networks get more and more complex, and maybe the consumers gets to be in a wider range, it's not only the sort of traditional telco users or consumers, it's also going out to industry, the various verticals. I think that there is a need to narrow that gap. And several standard bodies and open source projects has initiated new work items. So the study will take the progress from those. And the purpose is to make intent-driven interactions feasible in ZSM and fill gaps in the industry. The main task is to investigate and suggest ways to enrich the ZSM reference architecture with the possibility to receive, transform, convey, and act upon intents. And the study will provide guidelines on how to use intent-driven management interfaces and to outline recommendations of needed capabilities for intent-driven management within the CSM framework. The result from the study will either be used in an updated version of the CSM 002 architecture, reference architecture, or become the basis of a new group specification. Moving forward, a lot of good work has been done in TM Forum and their autonomous network initiative. And here is a comparison of what has been done there to fitting well into the CSM architecture. So we see the customer intent and being sort of transformed to business intent, further to service intent, and then sort of intents towards the resources upon the infrastructure. And you can see that sort of mapping here that the ZSM framework consumers would be the customer intent and the business intent. And then further on, the end-to-end service management domain will then be the way where the service intents are used, and then further down to the resources in sort of that are governed by the management domains. There is an important part of the work in TM Forum is the intent handling function. So the idea is to introduce a concept into the architecture of network operation, and introduce an architecture of intent handling built from intent handling functions, as you can see in the picture here. And this is an example of a hierarchy of intent handling, and other hierarchies are possible. So the proposal is to use the intent handling function as a basic building block for intent-based operations, and having the same kind of function in various parts of the network. But then, of course, doing different things and having different input and performing in a different way. But having the same function or same implementation even here would be helpful. That's the idea. So the intents exposed to human to machine use case are not the same as intent used for machine to machine purposes, of course. So that's maybe an exception. This intent handling function is proposed for a machine to machine purpose mainly. If you look at the dense mapping, schematic mapping of the intent to the ZSM architecture, you can see the communication services here with the consumer, and an intent handling function here. So the end-to-end service management domain can either transform or convey an intent towards the management domains, or interpret the intent and transform it into a set of services from the management domains. So it can look at the intent, and it can say, oh, you can see that these and these and these services should be employed to be able to meet this intent. And I think it's important here also to understand that the intents are very sort of depending on the context. So even if an intent is sort of perfectly understandable at the top, it doesn't make sense further down if it's not sort of interpreted in the context that the different the domains then understand. And furthermore, the management domain can either transform or convey an intent towards network resources, or interpret the intent and transform it into resource requests. And further on then down in the architecture here. So the idea from is to use this intent handling function then recursively within the architecture. So there are a number of definitions of intent, and we've been working with it back and forth if we should sort of adopt some special in sort of definition from any standards organization. But we think that we will use them, but we also want to sort of define what we will work with in CSM. So we've come up with something called the working definition that is most important then for CSM. We say that an intent emanates from a service or network consumer, and intent has a separate life cycle. So that's an important feature. An intent provides complementary guidance to an autonomous network regarding expectations from the customer or on service or network behavior. So a typical case would be that you have various sort of services that you run, and you have sort of communication between the end-to-end services domain and the service and the management domains, and that you would then complement that with his intent. But there's a special case. A zero-touch network shall be possible to be guided solely based on intent, so that you could in principle, if we go back here, you could in principle sort of run a total network here only with intents. There are a number of aspects that we're looking at in the study. Analysis. Sorry. So we will analyze existing domain and technology-specific intent models and intent-based interfaces, of course. And how document how these could be leveraged in the ZSM framework. And that will provides guidelines for generic intent-driven management interfaces and capabilities. Reusable by the management domains. Derived characteristics, requirements or characteristics of intent-driven interfaces. Investigate how to handle conflicting intents in the CSM end-to-end service management domain to mitigate issues and optimize coordination between management domains. We will study intent maintenance and negotiation to derive procedures for context-aware intent interpretation and translation. And as I said before, this part of sort of putting the intent into the context to make it sort of understandable is very important. And yet another aspect is to outline recommendations of needed capabilities for intent-driven management within the CSM framework, which may include then intent lifecycle management, intent inventory, knowledge management, related services, etc. And then we will include artificial intelligence, machine learning, if specifically linked to intent. Otherwise, it will defer to the ZSM 12 that we'll hear about in a minute. I think that's the end of my presentation. Are there any questions? or comments? We do have time for that.
Magnus, I think there is a question in the chat.
Okay, sorry. Yeah, I have a full screen here, so I'm trying to follow also. Let's see here if I can get. I have a separate screen here. Let's see if I can follow. Okay. Do you foresee impact of existing interfaces in ZSM architecture? No. Is that? Sorry, I'm a bit lost here. Is that the question?
Yeah, this is what I'm referring to. The question you can find on the swap card application.
I think there's a room for introducing new interfaces. Yeah, they're already in the architecture. It's been indicated. If we go back here, that in the architectural principles there is support for intent-based interfaces. So I think there is a need to both sort of update the existing interfaces and also maybe introduce new. So as I also said that there is intent should be seen as a complement to the purely service-based interactions. And then there is a new question here. Does the team think that there is a very big issue to be resolved about conflicting intents? One domain may want to optimize itself, but will need to sub-optimize to optimize end-to-end. I think we've indicated that we think this conflicting intents it's a big issue actually, because you would have sort of you have no control in sort of how the intents are put from different consumers, and you need to be able to resolve that. And then can intent handling be recursive? Yeah, to some extent, I think so. That you would have a sort of a intent handling function that will recursively handle the intent on different levels. Then there's a question: can we safely assume that human-to-machine interface is more natural language intent transformation or not? I think that the human-to-machine is especially in case here. I mean, it's emanating. I think from we see, if we look at the team forum here, that we see that the customer intent will emanate initially from a human. Although what I think in what we are looking at is mostly the machine-to-machine automation aspect here. So we will not look specifically into this translation of natural language, and we also think that there's a possibility that the intent that the customer actually put the intent in a more formal language, and there are suggestions within the team forum on what kind of modeling language to use for this. Yeah, and thanks for that explanation, Laurent. Okay, I think I'm at the end of my part of the session. Thank you very much.
So hi everyone, I'm Laurent. I hope you can hear me and see the slide I'm sharing. Milad, can you confirm that you can hear me well? And
it's okay, Laurent. It's
okay, good. Thank you. Thank you. So I'm Laurent Chevalier. I'm with Nokia. In that forum, I am presenting as rapporteur of ZSM 12, which is a new group specification on the topic of enablers for artificial intelligence-based network and service automation. So the AI technologies are and will become ever more integral part of service and network management, which give us to the question of how to operationalize AI technologies into such automation and management frameworks and embedded functions. The second aspect is that AI technologies integration is still manually intensive and case tailored. So we have limited automation in that respect, also limited portability and limited reusability of the different steps and processes that are used to integrate AI in networking environments. And it also poses a standardization challenge, which is how to enable multi-vendor, cross-use cases, cross-domains, interoperable and unified AI-based operations. Based on the above, most of that are always case-specific or for a single vendor solution. And so here in the specific topic of the ZSM Forum, this standardization challenge is a very important one. So starting with the view we try to develop in ZSM about this specific work is to think about a combined evolution of artificial intelligence and operations, and I mean service and network operations. So roughly speaking, you can figure out an evolution from today to a near future, a few years from now, with starting from, on the left side, this raw AI and automated operations. I will go into a bit more detail in the following slide and move on to more advanced forms and advanced use of both the AI technologies and the corresponding operations that you can have on the infrastructure, with the ultimate goal to reach a intuitive AI and autonomous ops. So these are just labels for the moment, but again, I will illustrate a bit what's inside. But the main message is that you will have AI technology evolution that stimulates the development of more powerful management and operations. And in parallel, you also have a need for the management and operations to evolve in order to be able to properly support this advancement of the AI capability. So this is really a combined evolution that needs to happen in order to take the most benefits of both. So starting with what we call the raw AI and automated operations is for us that we have right now a limited use of AI. So essentially only a subset of AI. We are looking mostly into machine learning and inside machine learning techniques, essentially about the most successful use so far, which is deep neural networks. But there are many other techniques that we could use. But right now it's limited use of these different panel of techniques. And also what we call big dumb data is that we have a lot of means now to collect a lot of things in the different network and service environments, but we are mostly blindly collecting everything we can without so much knowledge about exactly when and how we want to use that. In parallel, we have also isolated small-scale solutions with limited reuse. So this is good in one area because it's always a bit project or use case driven. You want to have complete application of AI techniques in your networking environment, but also the fact that as an operator or as a more framework approach, it's very challenging to develop things that can be reused across those different projects. Also, in terms of practice, right now in networking environment, we are mostly reusing techniques and algorithms developed in other domains and try to adapt them, retrofit them to the machine, to the network and service automation. So there is potentially a gap in terms of skills and fitness of the solutions to the networking environment. As said before, it's still a manually intensive integration. And we have quite control autonomy and confining scope use of AI. I mean, it's really on very limited use cases. There is not a lot of trust. So also the level of autonomy and automation that you allow, that you delegate to these artificial intelligence solutions are quite limited and controlled. In terms of security, there is very limited or no AI specific security measure right now. And overall in the landscape, quite a lack of standards in that area. If we continue to tomorrow or in a year or 2 years from now, we will reach advanced AI and AI-assisted ops, which is necessarily going into network adapted AI techniques. So how we can really have a better understanding and better development of AI techniques for our own network environment, and also going into a bit smarter data. So instead of collecting too many data, to try to be a bit more smart in what we collect and what we collect for. Also reaching the level where we have cross-use cases and larger scale application of AI-based solutions, but also in terms of the practice and know-how, so that we can leverage more this knowledge, this competency in AI in the networking environment for specifically network and service automation. We will also reach a stage where we have more AI-specific security techniques protecting network and service operation. So a more better combination between the two domains. And also we start to see emerging standards and basic interoperability. So we are roughly right now, we evaluate that we are between these two stages. Going to the lean AI and AI and power ops is what we aim to do next, which is really to be able to use the broadest set of AI techniques from both machine learning and machine reasoning without any limitation. And also to have the stage of intelligent data. So really to be able to collect just what is needed, not more, and also to be able to anticipate or predict what will be the most useful data to collect under which form and where to make it available. Also reaching a stage where we have AI as a service. So this is really a commodity being available to be consumed by any, let's say, location or services in terms of operation for the network, but also full-scale deployment and applicability of AI-enabled solutions, seamless design and integration. So now AI becomes really a part of the DNA of how we engineer network and services, not just a tool that we use at the end of the chain. It's really becoming, let's say, a supporting technology through the entire life cycle. In terms of security, also reaching higher level with guaranteed AI functional safety. So really stronger guarantees of how AI will behave. And in terms of standardization, of course, trying to reach a more comprehensive coverage of standardization and increased level of interoperability between all the solutions being developed and deployed. Finally, this is a bit more future looking. So difficult to predict when will this happen, but this is really the target objective that we will try to reach. So fully zero touch AI operations, complete use of machine reasoning, symbiotic human AI interactions, very important area for the future, reaching mission autonomy. So really being able to delegate with confidence to AI operations more and more tasks, having a fully transparent, trusting and open AI operation, and also reliable, robust and distributed AI solutions being used. Also for this work that we are doing in ZSM, it's very important to consider where and what type of AI applications or solutions we are considering to be in scope. So as you can see a bit in this diagram, there are many instances where you can have potential pieces of AI solutions or integrated AI solutions coming from, let's say, the data plane or forwarding plane, where you have a lot of different AI technologies embedded in different devices or different segments of the networks and the service infrastructures. Also in the controlling aspects of those environments, where you will have also different AI techniques for the control, but also appearance of more common data being used to control those different network segments. And in particular, area of interest for ZSM, which is the management layer, management plane, where, as you have seen in the previous sessions, that we have different management domains to cater for the different administrative or technological domains, and also this end-to-end service management domain, end-to-end service view, where you have different AI technologies developed and also the use of common data for the management purpose. What is also very important in these interactions between all these different AI instances is the interactions between the management plane and the other constituents, like the control plane and forwarding plane. So these interactions are also part of what we would like to cover, because they will not work in isolation. We have to cater for the interactions between those different planes for the integration and the use of AI. But as you can see also on the top, it's very important to consider also interactions with system that sits on top, such as the different operation centers, but also business service reports and digital storefronts using the ZSM terminology. We're also looking, if you look a bit into the diagonal axis, what we call AI workflow integration phases, is to really be able to, in ZSM, to support a full AI application lifecycle. So really from design to deployment and to production-ready AI application, how you embed those applications for the network and service automation. On the vertical axis, this is what I explained already a bit for this so-called continuum between management, control, and data. So really to be able to reach full AI ops, incorporating both AI-assisted, I will say a more gradual use of AI techniques to assist and augment human-driven operation, up to completely AI-driven or AI-empowered operation, where human will be more in a kind of supervising role. Also, finally, on the horizontal axis, if you consider the different network domains, and this will be very important for especially dynamic deployment consideration, is to be able to capture specificities for AI dependent from the different domains. So, for instance, you can have constraints from the distributivity versus the complexity versus performance. I mean, if you run different forms of AI in a smartphone or in a sensor, you don't have the same capacity and you don't have the same constraints in terms of where those instances are located, whether if you run different AI applications more closer or in a more centralized place, such as a data center or different central offices. So there is always this trade-off of distribution, complexity, and performance that needs to be handled in our management environment. And also, typically also other requirements could be, for instance, when you have real-time operations that you need to perform closer to the user or closer to the actuator of the system, and then you may have less flexibility to go back to more centralized areas or to ship data to this location of the computation. So in terms of standardization scope of ZSM 12, our key goal is to enable innovation and differentiation with AI in multi-vendor network service management environment. And for that, we will look into three main areas. The first one on the left, key enablers and functionality. So really what needs to be defined, specified to enable good use of AI in network and service management automation. The second area, which is support for deployment diversity. So when we have these different enablers, these different functional enablers, we also want to be able to use them into the broadest set of application or scenarios. So we want to see how we can reuse them and what adaptation we may have to also provide in order to make them applicable to many different use cases, many different settings in terms of deployment and different operation settings. And finally, trust and adoption. This is, again, a kind of orthogonal dimension, which is very important. Not only we have, let's say, development of the core technology with the enablers and the different scenarios, but we want to show what needs to come around that kind of trustworthy framework or trustworthy enablement framework, so that operators may gradually learn and transfer the trust in the operation of the, I would say, embedded AI operation. So also how to support this building of trust and confidence in the operation of AI. So these are the three main areas of investigation we will have in ZSM 12 in terms of standardization scope. And to, let's say, structure this into the work item, right now what we consider is, in fact, 6 key enabling areas, which one will not be in scope of standardization because this is looking really into the inner AI, but we have 5 main area of standardization we want to look into, which is execution, data, inter-AI, action, and governance. This is just to guide us into looking into the right enablers we need to define. So I will browse very, very quickly through those different enabling areas, but you have more information coming on in ZSM 12 too. So first, execution. This is really consideration for the environment over which the different AI embedded solutions will operate. So we consider that we'll compose a computing continuum, and we need to consider the diversity in this execution environment. So for instance, the infrastructure capability should support requirement and constraint from the AI application in terms of flexibility, efficiency ratio in any environment, be it on cloud or on premises or on devices. So considering this different flexibility, but also the fact that different deployment options of the AI component of solutions may be driven, for example, by real-time requirements and needs to be supported and played consistently. The second area, which we call data, is related to the notion of collecting the right data, but also enhancing those data with the right representation through metadata, and also enriching them with annotation or different types of semantic annotation, which will help into automating how we can bridge between the collection of data and the use of data by the different AI techniques. So to ensure the right access to the right data at the right place at the right time. Also to address how to cover for when we have lack of proper data, either because we have limited access to that or because there are some gaps in the measurement of the data. Addressing also the need to reach our description and expressiveness, again, as I said, with metadata and semantics. To balance the amount of data we will need to be collected by having more intelligent data, addressing different needs in terms of collecting a lot versus collecting good information, but also addressing collecting the right type of information and being able to assess whether the profile of input data fits also with, for instance, what the AI model was trained for. So addressing the drift between the distribution of the data and the outcome of the AI model, but also addressing everything related to data governance with proper support for security and privacy, etc. Inter-AI, this is really the area for everything has to do with when you have multiple AI applications, there will be multiple of them, as I showed in the previous slides. They will have interactions for different purposes, either for learning purposes, for decision coordination purposes. So we have to, in fact, be able to support a wide spectrum of learning approaches, ranging from fully centralized to fully distributed. And you have examples such as federated learning or other type of approaches that also, by definitions, are built about distributed assumptions, but also AI applications that can collaborate in learning different tasks or contribute collectively to solve a common problem. Coordination between multiple distributed AI applications, applicability of transfer learning, and trust relationship between these multiple AI applications. Let me just check quickly the chat. Okay, so I will really accelerate on that. So action, this is really how to map the output of the AI applications to the environment. So different forms of AI being more informative or imperative, but also being able to automate the mapping and the plumbing of this output of the AI to the right control and orchestration point. And how we can also support the fact that we have human in the loop for consent of the AI output, or to automate based on human knowledge, human expertise, where it will be the best way to actuate from the output of this AI application. So gradually also augment the human capabilities with that. Then finally, governance, which is a very important enabling area for ZSM 12. So to link with what Magnus mentions, how to go from an intent type of definition of the goals that we want to achieve with the services and the operations, and how this will translate into configuration and deployment of the AI-based applications. Also covering very important aspect related to what we've seen before with, for instance, data, how we can cover that through the intent expression, but also the fact that we need to reconcile between different AI, different expertises between networking and AI. So there's still a gap in our environment, in our domain with that. So how to gradually ramp up and close this gap. Also consider, for instance, this life cycle of AI application, how to integrate the different aspects that could be AI specific in the different CI/CD or DevOps type of environment, etc. So just to conclude, we are still early in the phase of ZSM 12. So this is a kind of indicative roadmap where we stand today in April 21, and we are still going through a number of, let's say, defining activities before reaching the actual specification that we want to have in ZSM 12. So looking into other work items in ZSM where we can have already support for AI, looking into external terminology and also state of the art to not redo what has been done, but build on top of the existing resources, and also going into finer refinement of the enabling areas. So as a conclusion, what we want to reach with ZSM 12 is better management and automation with AI inside, but also the corresponding part of doing better AI with the right management and automation framework capabilities. So what we want to do in ZSM 12 is to equip the ZSM framework with capabilities to have a full AI ops enablement. We aim to have a compact, so not too long document with stage 2 type of specification covering requirements, supporting management services and deployment scenarios. And you can find the latest draft of all the ZSM specification on the ZSM open area. Thank you for your attention.
Thank you, Laurent. Thank you, Magnus. Magnus will actually be back at 12:10, looking at zero-touch autonomous networks, ONAP, and ZSM. Thank you again, Magnus and Laurent.